Yeah, let's talk about cloud native deployments in air-gapped environment, which is a contradiction in itself. So the title contains a contradiction. But we try to make it possible. Who I am, it's not really interesting. I'm doing Kubernetes for 7 or 8 years now. From the very beginning, founded companies, consulting in the energy business, healthcare, and the German government. Created some pro bono projects, but this is not interesting. So this is a slide. What are we talking about? And we are talking about critical infrastructure, which is now here the German definition. In all other countries, there will be a similar definition. So we have, in German, we have this CRITIS regulation. And it's a very rough classification. Just to introduce you, it needs more than 500,000 people are involved if something goes really wrong. This is a very bad measure because then this means that the insurance for your glasses are more important than the waterworks. And definitely you can live without the insurance for your glasses, but not without water. Waterworks are mostly too small, and then we have to deal with it. I'm also doing something in transport and traffic lights, which is also not necessary because traffic works better if the traffic lights are switched out. This has been proven. Exception is tunnels, where you need ventilation. But the most important area is energy. So if we lose energy, then we have a real problem. And this means if we want to do Kubernetes in CRITIS energy, we need to be especially careful. Why? So the priority 0 is the transmission grid, which is more or less managing the electric current on every level, and what I'm talking about is the upper part here where you have 110 kilovolt and up. This means this is the area where the power plants are, where you have all kinds of medium and large industrial plants, something like this, and this is attached this way. It is run by transmission system operators, and effectively it's a very sophisticated IoT. And IoT, you know the joke, the S in IoT is for security, and that's the same here on that level. We have to fix this by isolating the environment, and we have to install everything air-gapped. So the isolation means we have a special need to work in a completely air-gapped environment. The security requirements are complex. We need a lot of resilience against floodwater, drought, topology on a European scale. Very often it's assumed, the transmission grid is just a copper plate. No, this is not the case. We have to include every transmission line and have to do it really carefully with very old protocols, SCADA from the 90s. It's has a lot of operational technologies. In the future, there will be smart meters, and the highest what we have at the moment is 500 kilovolt. And a lot of IT is involved, of course. The future will even be more complex. So if you have some devices here, and then you switch to that level, and in the future to something which is called vehicle to grid. You have lower voltage, but you have much more local networks, much more devices. The energy flow is bidirectional, so you can load a car and you can use a car as battery, and you will have a very complex security demand. If you have followed the news, some people needed 2 minutes to hack a Tesla, and if you think you have 1 million of these cars producing energy or consuming energy in the transmission grid and they can be hacked, you see what kind of problem we will have in the future. Why Kubernetes? So yeah, of course, we need more control. We have more devices. We have uncertainties in this area because we have to manage the weather, sun and wind for photovoltaic and wind energy. Locally, you have consumers and in the future producers. And we also have energy trading in that business. So this means depending on the price of the energy price even can negative, then you get paid if you consume energy, adds a lot of need for flexibility. And the computing power can only be done in a very complex system, like at the moment the natural choice is Kubernetes. So we have all these kind of devices and stakeholders. On the security side, this is one of the most security critical systems you can have. We have seen this in the last year when Russia attacked Ukraine. And what happened is the Ukrainian military and the German ENBW, which is a local energy provider, lost the control about wind turbines because they used the same satellite as the Ukrainian military. And what does it mean if you lose 5,800 wind turbines? This is the equivalent of 13 gigawatts. And it is known that the grid stability is designed for maximum hit of 3 gigawatts. And the modems have been bricked, so nothing happened immediately, but they lost control and they had to go to every device and reinstall software, update things, and definitely get back control. Also, physical attacks to operational technology in the field are possible. We are seeing drones around power plants or transmission systems, and all the systems are quite old and do not scale. So the rescue is, on the long run, use microservices. And now we have to talk about the security model, and effectively this is a security model. Here you have the internet, and then you have more and more secure zones until the very restricted high security zone. But effectively, if you compare it, this is a security model. It's a medieval castle. You have moats, walls, towers, bridges, kinds like this. This was quite stable, so it surrendered after 18 months of siege. So actually, it's not as bad as a security model, unless you think, yeah, this is your battlefield. So there is no way of doing moats and walls in a sea battle. And we have this system here. So we have standards. For example, in Germany, we have this BSI Grundschutz about containerization, about Kubernetes, which is a subset of CIS and NSA demands. And what completely misses in the moment is some security for a supply chain. So we don't have a collection of protections for supply chain. And to the rescue, I always use the DevSecOps Enterprise Container Hardening Guide and documents from the CNCF and the DoD, which is the best we can have, but we don't have a European or even German regulation at that moment for supply chains. And this makes it difficult. So let's look what does the CNCF and the DoD say. They use the DevOps process and added security to every part of the DevOps process. So this is DevSecOps. And you will see it starts with a threat model, secure coding, security as a code, SaaS, DaaS. This is more or less overstep. This is SonarCube. Pen testing is manual, digital signing, secure transfer, configuration, scans, patches, in production, audits. This all is necessary if you want to implement this process. I don't know a single company who has implemented everything, but you can try as most as possible to get as secure as possible. So this is Department of Defense and the CNCF who are supporting this. Another thing you see in this kind of environments, they all want to implement a software factory strategy. Software factory is not completely defined, but it's all about enabling, and this is a cloud native part you want to enable by using private or public clouds. You want a CI/CD pipeline, and you want to have the DevSecOps flavor of DevOps. And here in that area, this is a kind of agile part, and agile is also part of the software factory strategy. So you have to implement all this, and this normally, to introduce this in an environment where this is not happening, takes 5 years. Effectively 2 years if you only core the 80% of the core functions, but in such a conservative environment, it takes 5 years. So what can we do? Yes, to get everything into that environment, we have to check and scan everything. So the idea is to have one cluster which is at the border of your castle, more or less. And here you scan everything, you check everything, and you deploy everything on every cluster inside. And then finally, you also report everything which is happening to Splunk or Elastic or whatever you can do to get the information out of this cluster. So let's go through all the components. First step is Harbor, cloud native project, and it has a capability now of definitely scanning images. So you should scan every image which goes into your environment. This means we have to find a way that we use only images which are hardened and comply with our security regulations. The next thing what we want to do is kind of GitOps, so we want to have a Git available. And then, this is the ArgoCon, what comes into the game if we want to deploy it with Argo CD, because normally it's easier if you have a graphical user interface. Normally the people who are running these systems are Windows administrators, and then it's better to have something which is understandable for them. Finally, here you see we are logging everything, so it goes into either Splunk or Elastic, depends on your budget or your manpower, and you can definitely get information about everything. So you know that. Unfortunately, I cannot show you a real system from a customer, but this is the idea. You can deploy everything with a single mouse click and even do a rollback if you want. The setup of the management cluster is designed for easy maintenance and high security. So Harbor, Trivy, this means all images are scanned. It also serves as an internal registry. And we are exporting CVE lists. This is a funny thing because if you enable people to create CVE lists, the last thing I want to have in my private email is the CVE list of a critical system, because CVE lists normally are highly sensitive because it contains all the information you would need to hack into the system if you are already there. Please don't send me your CVE lists. This is something I always have to introduce into this project. So yes, I don't want to be CC'd with this kind of stuff. Better you don't send them anyway. The only thing you should do is export them to some kind of monitoring solution and don't mail it. A Git is necessary if you want to make Git. So Git is one of the first choices, but we're now looking into 4JO. Argo CD is definitely, as we have seen, the most promising project for rolling out GitOps with a user interface. And monitoring, with monitoring you get definitely this continuous security monitoring. Continuous means daily at this moment. And this is a central place where you can look into all all your changes. For example, Harbor has an interface to curl the CVE list, and then you can export the CVE list and push it directly into a monitoring solution. And then the monitoring solution can be used to alert you if a new CVE is introduced last night. And then you can decide how do you want to deal with the CVE. We are in a critical system, and this means if a CVE appears, we cannot turn off the critical system. So we have to deal with mitigation, we have to deal with pushing a new version rolled out without all these vulnerabilities. So these are the tools we use, and finally, Argo is the tool to roll it out. What are the results? So the things from the trenches. My personal record was an image with 735 vulnerabilities in critical infrastructure. 20% of them critical or high. The typical Microsoft containers based on Ubuntu, if they come out of the box, have 140 vulnerabilities. And I'm a big fan of strict enforcement of security, so we have to deal with it, because if you allow this enormous number of vulnerabilities, and you have not a single container, we have hundreds of them, this means security is completely blinded by false positives. So you find in some of these containers, you find development. So this 735 vulnerabilities means we had a development environment in that container, which is unnecessary. And typically you have 2 versions of Python, which is unnecessary. And we are pushing back, and then you see, okay, it's getting better and better, and sometimes you see a regression, like from one day to another, we had a log4j shell container in critical infrastructure. And then we talked to the vendor, and yeah, the first statement before that was our CISO would never allow to deliver insecure containers. And then you can show him, you delivered as a log4shell. What is your statement about this? It's sometimes even embarrassing, because third-party vendors are lying to you, and then security really becomes unpleasant. And this is not a problem I have. I can become unpleasant too if I see this kind of containers in production. And we have definitely to improve our security culture. This is out of the box, because I cannot show you the internal containers of a critical system. This is a Tomcat 9 out of the box with a lot of critical CVEs, critical and high. And this is not the state of security we can tolerate anymore in the future. If the bad guys are done with Microsoft Exchange and Outlook, and they will turn to Kubernetes, then we will all be punished if we tolerate this kind of containers. The limitation of this concept are we are not able to detect architecture flaws. So log4shell was an JNDI architecture flaw. We have to introduce and enforce separations of concerns. This is an old version of Elastic before they introduced operators. They just, in the very beginning, the init container needed special systemctl command, and then if you separate it, you can have a secure version and a privileged version, which is just going into a post statement as a daemon set. The experience, also to collect it, the entire system works. The impact of scanning containers is dramatic for the project. So I'm running a government project at the moment, and then we talked about enforcing distroless containers, because it's the only way to get rid of this crap. And this needed definitely some time, because then the developer said, yeah, we need more or less half a year to get our stuff distroless. This is okay, it's an effort. The customer, the German government will pay for this, but it has to be done. There's no excuse. Argo CD was one of the nicest projects integrating into that workflow. You can give a very fine-grained access to every cluster. You have user trials per application. It takes 1 day training to educate the staff. But not every Helm chart works out of the box. This might change, I hope, for the next versions. And also central monitoring helps a lot in these systems. One major problem in all these environments is the authentication. You need to configure logins and IAM for every application. So problem is the customers very often use Active Directory. Then you have to configure it 4 times. 1 time for your Kubernetes, 1 time for Harbor, 1 time for Git, 1 time for Argo CD. So there is definitely a need for having a unified IAM for all applications. If you go into OpenShift, there is one of these integrations, but this is not the standard. And Active Directory is definitely a major pain. You have to isolate it because you have Python one-liners which are able to hack into Active Directory and take over the total control. So you need network policies just in the case you have an Active Directory to isolate the Active Directory from the workload of your cluster as a side effect. The next steps in the future, we are not done with it. We want to sign everything. So we want to use SigStore and sign the artifacts. Definitely also uses the entire certificate authority. We want Recore as transparency logs because I don't want artifacts in the systems where I don't know the history. It could be that a developer signs something and it doesn't show up in an audit or in a review, and we need to know what's exactly in that portfolio. It's monitoring and root trust, so we should have a good chance of doing this. So what will we do? We will start with Git signing, then we sign the build artifacts, then protect the system itself, and then in the future we will promote only signed images. So as a Kubernetes container runtime, we use probably Creo. We can use Harbor or Argo CD and Flux just to support signed artifacts. And this means here in that picture, we can guarantee that here a third-party vendor has signed something and only signed images go into the system, then they will additionally scanned. Then we have the signed images here. We will use Argo CD for just promoting signed Git help charts. So this is the place where the Helm charts live. If we could have OCI images as Helm charts, then we would use this mechanism. And then it's only promoted if everything is signed. This is the future, and this is part, for example, of the German cloud-native government strategy. So every image there must be signed. What we are doing here is we are transitioning an active system to security by design. And this means security must be easy. We don't see a corporate security culture. Sometimes we have to really do a hard enforcement. And we see a lot of movement in the Kubernetes security, so mostly to the better. Basic flaws are removed. We see tools, scanners, config, signatures. And Argo CD here is a cornerstone. And that's it. Thank you for your attention. Here are my contact addresses, so you can mail me or get me on LinkedIn or on Chaos Social, Mastodon. And at the bottom, there are the resources for the links, so security trainings, how to harden containers, and how to deploy this management cluster. Thank you very much.